Question number 1 of JEE Main Paper 2026 April.
Let's begin with the first question. Let alpha and alpha plus 2, alpha is integer, be the root of the quadratic equation. The quadratic equation is x times x plus 2 plus x plus 1 times x plus 3 plus x plus 2 times x plus 4 continues to x plus n minus 1 times x plus n plus 1. All term, the sum of all term is equal to 4n, and n is a natural number. Actually, we need to find n plus alpha, the value of n plus alpha. So we need to find the value of n, then we need to find the value of alpha, then we need to find n plus alpha. At first look, we can see that a lot of terms are added together and it's very long. The only thing is, we need to find a pattern. First, we need to convert this entire expression into general terms. Then we need to add sigma notation to that general terms. Then we will move to the next step. Let's start with the first step. Look at the terms carefully and understand patterns. So from these terms, we will try to understand the patterns. So the first term, x times x plus 2. So the x is alone there. So we can write also the same like x plus 0 times x plus 2. And see, the terms are incrementing. The left side is incrementing by 1, 2, 3. It's a natural number. So the right side is incrementing 2, 3, 4. But from here and this side, difference is 2. See, 0 and 2, the difference is 2. So first we will assume that this position is k. Then what is the right side position? X plus k plus 2. If k is 0, then this will be k plus 2, this 2. The same thing we can apply here. If here is 1, then this right side will be x plus 2. So 1 plus 2 is 3. So we can make a general term according to this. The last term is x plus n minus 1. Then assume n minus 1 is k and the right side is n plus 1. So k plus 2 is n plus 1. So according to this pattern, we are going to write the general terms here. See, x plus k, the first x plus k here, then right side x plus k plus 2, the same thing, k here and k plus 2 here. So x plus k and times x plus k plus 2. This is the general term of this entire equation. Then we need to convert these general terms into a sigma notation. So we need to add, as per the question say, the entire sum of terms is equal to 4n. So the total sum, the summation start k is equal to 0 to n minus 1. When k is equal to 0 to n minus 1, the entire equation, the sum is 4n. This is the whole sum. When we convert the general terms into a summation notation, we will get an equation like this. Now we move to the next step. Now step number 2, expand the general terms. So we are going to expand x plus k times x plus k plus 2. We are expanding that form. So we are doing a small trick to expand these terms easily. So first is x plus k. Keep that x plus k as it is. But inside this x plus bracket, the x plus k inside this right hand side, we are making the x plus k into a single term. So we use the two brackets and make the x plus k as a single term plus 2. Now what we are going to do is we are opening the bracket by multiplying each term. So x plus k times x plus k is x plus k times x plus k, then x plus k times 2 plus x plus k times 2. So x plus k times x plus k is x plus k the whole square. Then 2 times x plus k is 2x plus k. Now we are going to open this bracket. A plus b the whole square. You know, everybody knows the equation. A plus b the whole square is equal to a square plus 2ab plus b square. So we use that equation and we are opening the bracket. So x square plus 2xk plus k square. Then the second term, x 2 times x is 2x plus 2k. So 2x plus 2k. So the final expansion form of x plus k times x plus k plus 2 is x square plus 2ks plus k square plus 2x plus 2k. Step number 3, put this inside the summation. So we are going to put all the expanded form of this equation into a summation. So summation k is equal to 0 to n minus 1, x square plus 2kx plus k square plus 2x plus 2k, all is equal to 4n. Now what we're going to do is we are splitting term by term. So we are going to find a summation of each term separately. So we get an equation like this. Now step 4, simplify each sum separately. Okay, so we are going to take each term separately and simplify it. The first one, summation of x square. So see, x square, there is no k there. So what we're going to do is we know that this x is independent of k, so x square will repeats n times. So we can write summation of x square is equal to nx square. From this moment, there is no summation there. We can simply write nx square. Next, second, summation of k is 0 to n minus 1, 2kx. So there is k there, but the 2x is a constant. So we can take the 2x outside the summation and let the summation of k keep as it is. We will see in the next step. So we can write 2x summation of k. Third one, summation of k0 to n minus 1, k square. So there is no other terms there, only k square is present. So keep the term as it is. Fourth one, summation of k0 to n minus 1, 2x. So there's no k. So 2x is also a constant and it's independent of k. So we can say that the 2x will repeats n times. So we can say 2nx. We can write 2nx. The fifth one is summation of k is 0 to n minus 1, 2k. The 2k, so 2 is constant there. So we can take the 2 outside the summation and we can write summation of k 0 to n minus 1 k as it is. After simplification each term separately and combining the result, we get the equation like this. Now we move to step 4. Use standard summation formula. We have two standard summation formula here. Summation k is equal to 0 to n minus 1 for k. That is sum of first n minus 1 integers. So what is that equation for that? N into n minus 1 divided by 2. So second one is sum of square of first n minus 1 integer. What is summation k is 0 to n minus 1 k square. So the formula for that is n into n minus 1 times 2n minus 1 divided by 6. So we use these two standard formulas. We substitute into our original equation in the place of summation k square and summation k here. So after substitution, we got an equation like that. Nx square plus 2x times n into n minus 1 divided by 2 and n into n minus 1 2n minus 1 divided by 6 plus 2nx plus 2 into n minus 1 divided by 2 is equal to 4n. So after doing some algebraic tricks to simplification, we cancel the terms to each numerator and denominator. Then again we got another equation. From that equation we look for some common terms. We have xn common here also xn, and here also nx is available here. So we can take the nx out. So what left here is n minus 1 and plus 2. So xn is out, then n minus 1 plus 2. So n minus plus 2 is nx n plus 1. After replacing these values to our equation, we got the equation like this: nx square plus nx n plus 1 plus n into n minus 1 to n minus 1 divided by 6 plus n into n minus 1 is equal to 4. Now step number 5, move everything one side. So we keep all the terms on the left side. So what is the right side is 4n. This 4n we are taking and replacing back to the left hand side. So what will happen? Nx square plus nx times n plus 1 n into n minus 1 to n minus 1 by 6 plus n into n minus 1 minus 4n is equal to 0. Now this equation look like a classic quadratic equation. We have x square term here, x term here, and the constant term here. So it's a classic quadratic equation. Now what else we can do? We can factor n. We can take n from each term and factor n out. See, n, we take n out and we got a x square plus x n plus 1 plus n into n minus 1 to n minus 1 divided by 6 plus n minus 1 minus 4 is equal to 0. Now listen. Now we need to analyze this equation. See, as per our question, it's saying n is a natural number. That means n is not 0. It's a non-zero number. So here, what we can say is product of two terms, or product of two number is equal to 0. That means either this number should be 0 or this number should be 0. Then only the answer will be 0. And the question itself saying n is a natural number, so n is not 0. So this term must be 0. So we can directly write this term equal to 0. Otherwise, we can say that n is a non-zero number. So we can divide both sides using n. So n is n cancel and 0 divided by n is 0. So then we can rewrite the equation like this. So the both method we can use. Now step number 6, simplify the constant term. So this is the constant term here. So we have x square term, x term, and constant term. So we are taking this constant term separately and going to do some simplification. So n minus 1 times 2n minus 1 divided by 6 plus n minus 1 minus 4. So we are doing some opening the bracket and expanding. So we get like this: 2n square minus n minus 2n plus 1 divided by n minus 1 minus 4. So do take the LCM 6 and make the common denominator 6, then do some simplification, and finally we got the equation like this: 2n square minus 3n plus 1 plus 6n minus 6 minus 24. They again do some algebraic arithmetics techniques, and finally we got this equation like this: 2n square plus 3n minus 29 divided by 6. So this is our constant term here. So replace the constant term to our original equation, and we got x square plus x times n plus 1 plus 2n square plus 3n minus 29 divided by 6 is equal to 0. Now this look like a perfect on a classic quadratic equation, the simplified form of our original quadratic equation. We got this classic form of quadratic equation. So x square term is here, x term is here, constant term is here. Now we move to the step 7. Use the root information. What information we have? Because alpha and alpha plus 2 are the roots of the given expression. That means this quadratic equation has two roots, alpha and alpha plus 2. So we have a special relationship between quadratic equation and its roots. It's called Vieta's relation. See a classic quadratic equation example: ax square plus bx plus c is equal to 0. In this quadratic equation, the roots are alpha and beta. So we know the roots already. Then we can make a relationship between these roots and its coefficient. See, take the sum of the roots alpha plus beta. So sum of the two roots alpha plus beta is equal to minus b by a. So b by a. So this is the relationship between the sum of the roots. So alpha plus beta is equal to minus b by a, and the product of the root alpha times beta is equal to c by a. So this is the relationship between roots and quadratic equation. So this, keep in mind this relationship. So we'll apply this relationship to our problem. So see, we have the two roots here, alpha and alpha plus 2. First we will take the sum of roots. What is sum of root? Alpha plus alpha plus 2. These are the sum of two roots. So we already know that b by a, b by, in this equation what is b? Coefficient of x is b, b is n plus 1, and coefficient of x square is 1. So we can say n plus 1 minus n plus 1 divided by 1. So this is the coefficient of x. After applying the Vieta's relation to our original equation, we got the value of alpha. See, alpha is equal to minus n plus 3 by 2. See, this is the simplification here. So alpha plus 2, sum of two roots, minus n plus 1 divided by 1. So 2 alpha plus 2 is equal to minus n plus 1, and 2 alpha, we got the equation, and finally alpha is equal to minus n plus 3 divided by 2. Here we open the bracket and we take the negative out. That's why it's come n plus 3 here. So take the minus sign out. That's why n plus 3 come here. So alpha value is equal to minus n plus 3 divided by 2. Now we find alpha plus 2, because the next step we are going to find the product of two roots. So we need the value of alpha plus 2 there. That's why we are taking alpha plus 2 value also here. So do some arithmetics and algebraic techniques. We got the value of alpha plus 2, 1 minus n by 2. So these two values we are substituting in the next step by taking the product of roots. Now let's see the step number 8, product of roots. As per the Vieta's relationship, we know that product of roots is c by a. C by a is constant divided by the coefficient of x square. So c is constant is 2n square plus 3n minus 29 divided by 6. So coefficient of x, I mean a is 1, so neglect that one. So as per the Vieta's relationship, product of two roots is 2n square plus 3n minus 29 divided by 6. But we have already calculated the value of alpha and alpha plus 2 here. So alpha equation we have, alpha value we have here, and alpha plus 2 value also we have. So substitute these two values to our original equation. So we replace the alpha and alpha plus 2 values here. So minus n plus 3 divided by 2 and 1 minus n by 2. So just do some multiplication on the denominator side, minus n plus 3 times 1 minus n divided by 4. Now see, now we switch the two terms here, because we need to remove this minus sign from there, because if we have the minus sign there, it's complicated to do the simplification. So we give this minus sign to 1 minus n. So what will happen to 1 minus n? The sign will change. So n minus 1. The 1 minus will change to n minus 1. So now it's a clear and clean form. N minus 1 times n plus 1, n plus 3 divided by 4. So just open the bracket by multiplying each term. So we got the answer. We got the equation n square plus 3n minus n by minus 3 divided by 4. So equate this to the right hand side. So now what we need to remove the denominator. So we need to eliminate the denominator. Least common multiply is 12. So multiply both sides using 12. So what happened? Here 4 cancel, 6 cancel, 12 cancel, and here it will be 3 here and here 2. So what happens? So 3 times n square plus 2n minus 3 is equal to 2n square plus 3n minus 29 divided by 2. Now open the bracket by multiplying 3 into this each term and here 2 to the each terms, and we get 3n square plus 6n minus 9 on the left hand side, and the right hand side is 4n square plus 6n minus 58 on the right hand side. So doing some algebraic techniques, and we find the values minus n square is equal to 49 here, and so the n value is plus or minus 7. So we got the value of n is equal to plus or minus 7. See, we know that n is a natural number, so n is not negative and not 0. So we can only take 7. N is equal to 7. So we take the value n is equal to 7. Now we have the value of n, and we need to find the value of alpha. So substitute the value of n in the alpha equation. So alpha equation is minus n plus 3 by 2. So after substitute the value of n in the equation, we got the value of alpha is minus 5. So now we have n value and alpha value. So we are moving to the final question. N plus alpha. Find value of n plus alpha. So substitute the values 7 plus minus 5. So the final answer is 2. So n plus alpha is equal to 2. So the option number 3 is the correct answer.